Hi, I'm Ben, student ID 1039435564, and I covered the supervised embedding model. So I just want to start off by going through the actual embedding net model. So here we've got our backbone, it's a ResNet 18. We load the waves, and then this loop here specifies which layers to freeze. So we froze the convolutional one layer, layer one, and layer two. We then proceed to go construct the full model. So you can see all these self initializations are the actual backbone. And then here we've got the embedding head. So that consists of one straight through linear layer and then one batch normalization layer. And that actually gives us our 256 dimensions. Now, for the supervisation model, because compared to triplet, it's actually outputting 4,000 logits for each identity, with each logit representing the probability that the presented image belongs to that identity. It means that we also need to attach this self.classifier head. And you can see that's set up here where this self.classifier head, 256, so an embedding for each one, by the number of classes for each logit, but only if the training mode equals supervised, else none. Then you can also see here the training mode is supervised, and we return the embeddings, and we return the self.classifier, which has all that logit information. I'll just briefly walk through the training script as well, so you can see I've got a whole bunch of argparse arguments, so epochs, batch size, learning rate decay, number of workers argument, and a subset. This is because it was a really large training. Before I went onto Google Colab, I had to experiment using a subset. I think something else to point out will be the learning rate decay. So see here, I've got a learning rate scheduler with cosine annealing. In my experience, it's worked pretty well for complex tasks. So that's what I chose to use off the bat. And then a gradient scalar. This was just to speed up the training process when I was running it locally. I think that's it from me. I think I've pointed out everything I want to do. Thank you.
I'm Heath Sullivan, student number 1053711303, and I'm responsible for the inference code of the facial recognition system. We're starting at the webcam loop here, where we import the MTCNN, which is a pre-trained model from Torch. It can recognize faces, but crops faces before passing it to the model for embedding. I then want to go over the if liveness equals spoof loop. If it's a spoof, it's not a real person, so we don't bother embedding. Else, we use the get embedding function, which accepts the cropped image of the face from the MTCNN model. The next parameter it takes is the type of embedding model it takes here, which is either the supervised model or the triplet model. And then depending on the device, whether it's a GPU or CPU, it will change between either of those. Ben covered this in the previous section. So then I want to go to the verify face function, which is right here. Now, this compares the embeddings to the embeddings stored in a database. This is just a dictionary with name, keys, and embedding values. This accepts a threshold based on the UI slider. You can adjust that to different thresholds. I'm going to go into this with control click so we can go through the loop. Now, this loop iterates through every name and embedding pair in the database. It then calculates the dot product between each registered embedding and the embedding calculated at inference, because both embeddings are both L2 normalized. This is equivalent to the cosine singularity. And that is the components of the inference code that I implemented for this project. Thank you.
Hi, my name is Golden Voon. Today I will briefly explain the emotion detection model that I implement into the facial recognition system. For the dataset, I use FER 2013, which contains the facial expression image grouped into 7 classes: angry, disgust, happy, surprised, and so on. On the screen, I'm sharing the happy folders. These are the examples show the type of facial feature that the model used to learn. I finally designed efficient net B0 as my final backbone of the emotion detection model. And in the UI, the detected face is cropped from a main system and passed into the emotion model. And when I smile, yeah, it will detect as happy with a confidence. Yeah, it will also show predict as happy, and the temporal refined model also recognize it as happy based on the recent frame consistency with a higher confidence as well. That is my overall emotion detection model. Thank you so much.
Hi, I'm Jia. For my part, I implemented the anti-spoofing module, also known as liveness detection. So now I will run through all of the code first, and then later I will show like how the thing's working. So first of all, yeah, for this module, the purpose is to identify whether this is a real person or spoofing attack. So I trained a ResNet 18 binary classifier for this task. I prepare my liveness dataset. The dataset is from Kaggle, and I was already put the link inside the report. And then I split my dataset to training, testing, and validation. And then after that, I trained the liveness model. Yeah, this is the backbone here. I'm using the dropout 0.3 and the features now is only 2, live or spoof. So now I will demonstrate how the liveness detection working. So you can see now the liveness detection is disabled because here we have a to go. When I turn on, it will show like, yeah, this is the live person. And with the green box, if I'm showing the image from my phone screen, it will show spoof detected. Okay, so you can see here, like it's showing spoof detected and with the red boxes there. Yeah, that's how it works. My innovative features, I added a random tree gesture challenge to the attendance system. So after the systems recognize the user's face, it does not immediately mark the users as fully verified. As you can see here is red box. So it will instead it asks the user, so I will show you now, open palm, peace, and thumbs up. Okay, so the box will change to green. And another thing we need to take note is it is only for the users who registered. If I delete the register face, it will show unknown, and even though the features is on, it will not showing the gesture challenge. So only when I register it again, register, yeah, the Zoe's features only come out. The model I use is a random forest classifier. So that's all from my innovative features. Thank you.
So in this section, I'll be talking about the training triplet model. This is mainly used to classify faces directly, but to train an embedding model. This means the model learns to represent each face as a vector, where faces of the same person are closer together and faces of different people are further apart. The main function used here is the semi-hard triplet loss. It works with 3 examples: the anchor face, a positive phase from the same person, and a negative phase from different person. Code selects semi-hard negatives, meaning negatives that are still close enough to be useful for training, but not impossible cases. Then we have the val approach function. It is the same kind of loss calculation on validation data, but without training the model, without updating the model. It checks how well the model generalizes and saves the model as triplet best when validation loss improves. So overall, this file trains the face embedding model used later for verification.
Hi, this project is a real-time face recognition attendance system. We go to our data our pre-processing data set code, which is right here. Essentially, this is all the images need to be pre-processed into a consistent format. So we define it into 4 source directories, which you can see here, and they're resized to a 224 by 224 pixels, which is expected by our CNN backbone. So that function walks through every source directly and it pairs each image with its output and is mirrored into the data process folder. And then each image is converted to a RGB to handle the grayscale and files consistently, and then resized and saved to a higher quality. And we use a script to use 8 parallel workers via Python's multi-processing pool to process images simultaneously. And also for my innovation feature, I just did this temporal liveness dashboard. Essentially, it using CNN network and GRU. Essentially, it just tries to identify and stop spoofing.